Hi everyone. I want to solve one of the questions from a study book which I skipped, but I have been receiving questions from the students regarding this question, and I want to make sure everything is clear regarding the work done by the external force, which is the work done by me, the work done by the electric field, and the change in potential energy. Yeah, before I start this question, I want to clarify this, guys. Look, the change in potential energy is always equal to the work done by F external, that's the work done by us, which is equal to the minus the work done by the electric field or electric force. 'Cause electric force comes from the electric field. Yeah. So if the work done by me, by the external force is positive, delta U is positive, therefore the potential energy of the object of the charge would increase, and the work done by the electric field would be negative. Because if the work done by us is positive, the work done by the electric field is negative, and the potential energy increases. That's what this equation says. Now let's read this example. An electron moves from point I to F in the direction of the uniform electric field. During this displacement, the work done by the electric field is positive and the potential energy of the system increases. That's part A. And part B, C through D, it talks about if the work done by field is negative, the potential energy increases, and then the work done by field. So they're going to change the work done by field positive or negative, potential energy increasing or decreasing, or it doesn't change. So let's see what will happen to the work done by electric field. Is it positive or negative? I want to know if the potential energy of the electron is increasing or decreasing. Okay, so guys, you can look at this in two different ways. First of all, if you remember, I said when you're given the electric field line or lines, what you could do, you could put a positive plate in here and you could put a negative plate in here, because the electric field lines always they point from the positive to the negative plates. So you could draw your plates. Now you're asking me to put an electron in here, a negative charge, and try to move it from I to F. If you remember in our exam prep session, I said if a charge is moving towards the same sign plate, yeah, you have a negative charge is moving towards a negative plate, the potential energy increases. That means that delta U is positive. The work done by us is positive. The work done by the electric field is negative. Yeah, so I mentioned that in our class. I said if a charge is moving towards the negative sign plate, it's a negative charge and is moving towards the same sign plate, delta U increases. The work done by us is positive. The work done by electric field is negative. So the answer in this case would be B. The work done by the field is negative and the potential energy of the electron field system increases. That's method one. Method two, what you could do, you could draw the electric force on the negative charge. We said that if there is a negative charge in here, the force from the electric field on it, it's going to be in the opposite direction of the field lines because the charge is negative. So Fe is negative, is to the left. So you guys see that delta R, which is from I to F, is to the right, and electric force is to the left. So the work done by the electric field is negative because F and delta R are in the opposite direction. If the work done by the electric field is negative, the work done by us is positive according to this equation, and delta U is positive, meaning that the potential energy would increase.